Alright, so in today's video we're going to be talking about the gas laws of respiratory physiology. We've got Boyle's law, Charles's law, Dalton's law, and Henry's law. Alright, so we'll start off with Boyle's law. This law states that as volume rises, pressure drops. This means that volume and pressure are inversely proportional. When you inhale, the pressure drops as the diaphragm is pushing downwards and air is entering the lungs and expanding. When you exhale, the diaphragm rises and the volume decreases and the pressure rises. Next, we've got Dalton's law. This law states that total atmospheric pressure is equal to the partial pressure of individual gases. So let me unpack that a little bit more. Atmospheric pressure is the air all around us. The four primary gases involved in air is nitrogen, oxygen, carbon dioxide, water, and some quantitatively minor gases like methane, argon, neon, helium, and a whole bunch of other things that really just contribute to the air all around us, which I won't get into right now. So the other side to that is the partial pressure, which is the separate contributions of gas. And we have an equation for that, which is the percent of gas multiplied by the atmospheric pressure. Here's a quick example problem of what I just said. So oxygen makes up about 20.9% of atmospheric pressure at sea level. We multiply that by 760 milligrams of mercury, which is the atmospheric pressure at sea level. And we get 159 milligrams of mercury, which is the partial pressure of oxygen. Dalton's law contributes to alveolar gas exchange. It helps us understand the makeup of the gas inside those alveolar sacs. Following off of that, Henry's law states that the amount of dissolved gas in a liquid can only be determined by the partial pressure. Gas exchange really cannot happen unless the partial pressure of oxygen in the alveoli is greater than the partial pressure of oxygen in the blood capillaries, because gas moves to lower pressure gradients. Inversely, we've got carbon dioxide. The partial pressure of carbon dioxide has to be higher in the blood capillaries than the partial pressure of carbon dioxide in the alveoli. Lastly, we'll talk about Charles's law, which states that pressure is proportional to volume. But this law is definitely the least prevalent in the respiratory system because the body's temperature is relatively consistent.